Good afternoon, ladies and gentlemen. So welcome you again, BBSKATI final. Still our lesson mathematics, Somera Muddiiro. Again, I'm just going to continue what you are doing last time, where we had almost got done with the collinearity of vectors. Also, we did the pair of vectors. We are going to move ahead and look at how we can divide a line. Last time we had introduced that, but we are going to introduce it again, and we do more questions concerning division of a line, because you can still divide a line in very many proportions where we use the given ratios. We are going to look at that. Then this will take us to the vector diagrams. I've done it intentionally that I want us to first cover everything, whatever concept we need. That's why I looked at the pair of vectors, looked at the collinearity of vectors. Now we want to look at how we can divide a line, or so we can look. We're going to express terms of vectors. So after doing all this, the vector diagrams will become easy, in that everything will be okay, because you have covered everything from the start. Positional vectors, everything will be done. So now working out on the vector diagram is going to be very, very easy, because every single concept that you are going to use in the diagram is going to be covered. And even today we'll be doing some numbers, which are where we can draw the diagram on our own, or even if you want, still you can do the number without drawing the diagram. So we're going to look at that. And let's have a short prayer before we start. Lord, we thank you for life you have given unto us. We thank you for everything, even the opportunity that we have right now to have this lesson. Come and guide us as we have it, that understand everything that we're going to study. In Jesus' mighty name I've prayed. Amen. So we are going to first look at how we can divide in different ratios, and so we can express this in very many ways. So I want you to be able to get in the various ways that they can give you a given ratio, because they can give you a line and they say maybe a point divides in ratio of this to this. Sometimes they can give it to you when they are giving you maybe like what you covered about parallel vectors. They can give you a scalar. They can express them in terms of scalars, like saying maybe AB equals to 3CB. So something like that, you need to know how to deal with such cases. And let us look at this. So for example, when we have, so I can call it proportional division of the line. Division of a line. So if you have something like this, you want to divide this line, and assuming we have a line AB, consider line AB. So if you're having line AB, and this is what I have A here, also have my B here. So we are going to have a point that divides this line. We are going to have a point, you can have a point dividing this line. And in this case, not dividing the line into two equal parts, but you can have it somewhere. Maybe this is going to be, this can be our point P. We have point P. So if at all this P, point P is dividing line AB such that we have here 2, maybe here we are having, so this is bigger, you can make it 2, maybe this is 1. So we can have that. So it means that we're having this point P dividing line AB. And so we use some terms here. We have what you call internal division, so we have the external division. Or they can say, now in this case, since this point P is dividing, look at it, is in between the 2 points A and B. So we say point P divides this line AB internally. It divides internally because it is inside here. But also we are going to look at sometimes when we have the external division, where we have this point P is outside. It's outside the line AB. We can also have that. So this is called internal division, where the point is within the line, not outside. So what we do here is that we can say, because this is 2, this is 1, we can express this in very many ways, this information given. So we are saying that we can still look at this and say that this means that AP, if I get AP to PB, this will give us 2 to 1. I can have that. So other will give me this formation. They can give us AP to PB equals 2 to 1. We can have something like that. And see, this one represents this. So I can give you this, it still implies this. Look at this also. Other person can tell you, because now these ratios are the same thing as having AP out of, now these are, I always want to move the vector symbols. So see, we are going to have AP divided by PB. So when you have the arrows, the vectors, no? Since we are looking at the vectors. And now also, if you don't have, you just have only no arrow, we just have a line up, that means it's a line segment. So it means that still, if you have AP out of PB, it's equals to 2 out of 1. You can also have that. So it means that we can still cross multiply. You can cross multiply and end up having AP. So you can say AP still can be equal to 2 PB. So all these are different forms in which they can give me this information. So we are saying we can have AP to PB equals 2 to 1. I can still give you this, that AP equals to 2 PB. They can give us still this. Another information that you can also get here is that I can express AP in terms of AB. And that's what we are going to use commonly. If you look at most of the questions, you need to know how to express AP in terms of AB. And this is how we do it. Because look at AB. AB starts from here, A is here, then up to B. So it means that you can get the total ratio, and this will be 2 plus 1. So it means that total ratio of, if you are to look at AB, it is AP plus PB, and this will be 3. And that implies that if I want to get AP, because this is a portion of the line, so if I want to get AP, or if I want to express AP in terms of AB, AP will be 2 out of the ratio, which is 3. So AP is going to be only 2/3 of AB. Let's do it here. So still it means that, again, total ratio, which is going to be 3, it means that AP can also be equal to 2 out of 3 of AB. We can have that. So we said I'm putting them in vector forms. That's why I'm putting the arrow. So we are saying that still, if you look at the line, which is APB, we can still have 2 for AP. That's a portion for AP. Then out of 3, because 3 is total ratio, and we are looking at the whole line, which is AB. So it means that AP can be equal to 2 out of 3 of AB. Another person can also look at, PB. PB. So when I take PB, it means that PB will also be equal to 1 out of 3 of AB. You can also have that. So if I want to get PB, it will be 1 out of 3 of AB. Then we have to be very careful. When we talk about PB, others can ask you to find BP. You see here I'm using AB because I'm starting from this side. I'm starting from A going this side. So I have AP, so it's 2/3 of AB. I have PB, it is 1 out of 3 of AB. But if you are coming from this side, for example, if you want to get like BP, then BP will be 1 out of 3 still of BA. So the direction matters a lot here, and they're saying that we're going to use this in vectors. The direction matters a lot. If I start from this side of B, and I'm getting BP, so it has to be 1/3 of BA. So we can look at this. We can say BP can also be equal to 1/3 of BA, 1/3 BA. We can have that. What you need to also look at here carefully is that still BP can be negative. We can still get from here because BP is negative PB. And this negative PB, we can divide by negative to go to this side. PB becomes negative AB. And since negative AB is the same as BA, that's why we get something like this. So it comes from that, knowing that this one, PB, is the same thing. BP is the same as negative of PB. When I take negative this side, then so we end up having this one here. So still, even if I want to get PA, the same concept is going to apply. For PA, still it will be PA. This can still be 2/3 of B, like that, 2/3 of BA. But I'm saying that you can still get these ones from from AP. I can still get PA from AP. Let me just try to show this to you. Because if I have AP here, like here I'm having AP and I want to just get without maybe, we have understood that this one is okay, depending on the direction I'm taking. So if I'm starting from B, then I have to use BA. PA, I have to use also PA, because I'm moving from the side of B, I'm getting BA. But look at this, if I want to also, I can also get from here. All I can do here is that I can say that this, you know that PA, I want you to understand this, you know, it's not about cramming, but understanding the concept. PA is negative AP, we covered that one some time back. PA is negative AP. So it means that I can still have negative, I can say, when I put here PA, because I can still have PA here, which is negative, not PA is negative AP. So it means that still AP can be equal to negative PA. So look at this. So it means AP is the same as negative PA, that one there. So it means that I can still come back here, where I've been having PA, I can put there negative. Where I've been having AP, I can put there negative PA, like that. Then still this will be 2/3 of AB. So I can divide by negative. When negative comes this side, it means I'll be having my PA being equal to 2/3 of negative AB. But again, that negative AB is the same as BA. We just have to change where we are starting from. So see, we end up having PA as 2/3 or 2/3 of BA. So it is the same thing. It is the same information. But see, even if you don't know this one here, we have seen from the line, it matters where you're starting from. If I'm starting from the ends of B, then I have to use BA, because I'm saying BP, so I use BA. But if I'm starting from this end of A, so we have PB, then I can use AB, because these are vectors. And for vectors, we say the vector has both magnitude and direction. It has both. That's why the arrow here represents direction. It matters a lot when you're dealing with vectors. So we have to be very careful with this. So that's what we look at. And this one we said it is internal. P divides AB internally. We need to understand that. That's how we need to know how to work out these ratios. They can give me this, they can give me this, they can give me just that AP to PB is 2:1. They ask me to find AP. So that AP is 2/3 of AB. I must know that. And also we have the external division. This is not so common, but still we need to understand, we need to know how to work out or how to deal with the external division. For example, external division now, it means that, so we say this, the first one, this is internal division, saying that P, we say can divides AB. If you look at that, so you can say P divides AB, line AB internally. Yeah, we can have that. And we are going to work out very many numbers. We are going to do numbers to address. And most of the questions you find here in O level, they're about internal division, but also we can find one or two concerning external division, where the point P, which is dividing, is outside the line. We are going to see that. Then also, before going to something else, we can also look at the midpoint. We can look at the midpoint, and we covered midpoint in senior 1, and also in daily life we can understand what we mean by midpoint. So midpoint, what it does, it divides the line into 2 equal parts, because it's a point passing in the middle of the line. And in terms of coordinates, we know how to get the midpoint. But in this case, we want to see it in terms of vectors. So if P, talk about it here. If P, now in this case, the ratio will be 1:1. If P, I'm saying if P divides line AB, if P divides line AB, line AB, such that so in this case I'm saying AP to PB, AP to PB, ratio of AP to PB equals to 1 to 1. The ratio of AP to PB equals to 1 1. Then P is said to be a midpoint. It's said to be a midpoint of AB. They're saying here then P is said to be a midpoint. Said to be a midpoint of AB, of line AB. So sometimes they won't tell you that this is, maybe they won't give you this ratio is 1 to 1. They just say P is a midpoint, so they leave it for you. I don't understand how we handle the midpoint. So midpoint, if P is a midpoint, means that I will be having my line, which is AB. So it means that P must pass in the middle of this line. So this is 1, this is 1. You understand how we handle the midpoint. So see, if I want to get like AP, it means that AP in this case will be still 1 out of the ratio, which is going to be 2. It's going to be 1 out of 2. It's half of AB, to be like that. So I really want you to be able to work out these ones here. So it means that AP equals to a half of AB. Then still, if I want to get PB, still this PB will be equals to a half of AB. So this is when P is a midpoint. So it depends on what you are looking for. If I want to start from this side, still it will be true that BP will be equal to half of BA. So the direction matters a lot here if you're handling the vectors. So we can say still that our BP can still be equal to a half of BA. So I wanted these things to be clear to you before we start working out some examples. So we need to now to interpret these questions. Where they say this is the midpoint. Now the midpoint is going to divide in a ratio of 1 to 1. So if you want to get AP, it is a half of AB. If I want to get PB, still it's a half of AB. If I'm moving from this side, I understand that if I'm getting BP, still I maintain the order. It now will become BA. The same thing if I want to get PA. If I want to get to PA, it's the same thing. Still it will be a half BA. So still we said we can still prove these things. We can still prove for PA starting from this, and I've shown you how we can do it. So this is how we work out those numbers. You have to be familiar, will be well conversant with these ratios here, talking about midpoint, and most commonly the internal division. But also we are going to see external division. I will give you some numbers with some few about external. But most questions you find them here, they will be internal division. External once in a while you can find. So I want us to work out some examples concerning this. Then we are also going to mix up with some few diagrams, and also we'll be doing the external division. Now we have those questions there. They are going to put for us the questions, and we are going to do one by one as time is going to allow us to do it. So we're having the first number there. They're giving us that given that OA equals to -2. So please you put down the questions, or if you have a smartphone, if you have a camera, you just capture the questions, you copy them later. So we're having OA given by that -2, 2. Remember, this is the position vector. We talked about that we get it in reference to the origin, -2, 2. Also, they are giving us that OB is given also as 8, 4. That is our OB, 8, 4. And they are saying M is a point on AB such that AM to MB, AM to MB equals to 1 to 1. That's what they are giving us, equals to 1 to 1. And they're saying find AB, AM, and OM. So we need to get AB as our part A. We need to get AM as our part B. Also, we need also to work out OM. So we're having those 3 parts on that number 1. So we have those 3 parts, and we want to see how can we work out this number, because I know some of us, these are still some of the challenges that we have in vectors, but after harmonizing this, when you go even to diagrams, things will be very, very okay. So let us look at how we are going to work out this question. Let us see how we do this. So we are being given OA and OB. I'll say that these are vectors, Bayesian vectors. They have got reference the origin. It means that this O is represent the origin, OA, OB. Now they're asking us to find AB. Want us to find AB. What about AB? So that AB, we can still get in very many ways, and you have been doing this so many times. So AB can be got using OB minus OA. So you look at the last one here, so it becomes OB minus OA. So we are going to have our AB, and this will be equal to OB, then minus OA. That's what we are going to have. So AB equals to OB minus OA. And so I told you, even if you just say it's going to be the same thing as AO, we have been doing that so many times. But I also want to remind you again. So if you have AB, it can still be the same thing as AO, then plus OP. Another person can use this, there's no problem. But knowing that this AO is the same as negative OA, so this one is the same as negative OA, that's why we end up getting OB minus OA. We did that so many times. So we have this AB equals to OB minus OA. I just come back and make substitutions. So my AB will be OB, which is 8. This is 4. Then minus my OA, which is negative 2, 2. So I'll be having my AB here. I'll be having my AB. So we subtract these ones. So this is A, 8, then minus negative 2. So this will give us a plus. So I'll end up having 8 plus 2, which will be a 10. So I have a 10 up here. Then also down we have 4 minus 2, which will become a 2. So I always want you to be very careful when you have these negative signs, because there are many cases of students to fail to work out this when you have minus negative. So be very careful. So we have 8 minus negative, so we end up getting a positive, which will be 10. And 4 minus 2, I get my 2 down there. So that's my AB. Next, they want me to find AM. Want me to find AM. So in this case, we are going to apply, because AB we could just find, since we had OA, we had OP, so it was very easy for me to get AB, even without using the ratios and so on. Now we go to AM. AM, let's see how we are going to do it. If you look at AM here, AM would have been so easy, because now that AM can be, so I want to start from what we know. We know AM can be the same thing as getting OM, still minus O. And don't fear to state what you know if you are dealing with the vectors. Don't fear, you start with what you know. So at least we know this one from what we have been covering. We have AM the same as OM minus OA. But as you look at what we have, we have OA, good, but OM we don't have. We don't have OM. So it means that this method will not help us. Why? OA I do have, yes. OM I don't have, and I'm looking for AM. So these two I don't have them, so there's no way I'm going to use this method. It would be okay if I had OM, but we don't have OM. So it means that I cannot use this. So this takes us to look at the line on the ratio given. So it means that I have to get AM by expressing it in terms of AB, because at least for I have A, I also have the B, and also I've got the AB actually. So I can still look at this line. I can look at the ratio given and to me. So they told me that if this is A, then we are having M, and also we are having the B. And they told me that AM
to MB is 1 to 1. AM to MB, this is what they gave us, that AM to MB equals to 1 to 1. So it means that this will be a 1, even this will be a 1. So if it's dividing, having a ratio as 1 to 1 means that AM was a midpoint of AB. So what I have to do to get AM, I'm going to set my AM will be equal to 1. This is 1 out of 2. 2 is the sum, not the ratio. So I get 1 out of a sum of 1 to 1 plus 1, which is 2. Then of AB. Yes, I'll be having this. So AM will be equal to a half of AB. So this is now okay because AB I've already got. So just going to substitute for AB, then I get what they want. So AM now becomes a half, two brackets, we have our AB, which is 10 to 10 to. And we covered these ones at the start. That's why I was saying that as we move on, if you have been following these things become so easy. Now with these concepts, we cover them at the start. I mean, say that this half multiplies 10, also multiplies the 2. So I'll be having a half times 10, which will give me a 5. And also I'll be having a half times 2, which will give me a 1. So it means that my AM becomes 5 2. Becomes 5 2. Why this half multiplies 10? Is like having 10 divided by 2, you get 5. 2 divided by 2, oh, this becomes 1. You get 1. Like that. So that becomes my AM. That's my AM. Now next they want me to find OM. OM. What they want us to get here is the position vector of M. They want me to get OM. But remember, I've already got the AM. So OM here becomes a little bit easier since we have AM. And most times when you look at these vectors, they're going to be in a way that when you get the first part, it's going to help you to work out the second, help you to get the third. So you have to move in that order. I don't expect you to handle vectors and you, like for this case, you jump from AB, you don't do AB, you don't do AM, you go to part C. It will become so hard for you. I don't expect you to just move from nowhere, you do AM without doing AB. So try to move in that order for vectors. Most times you find that when you get the first part, it's going to help you in the second, this one is going to, so the way they are arranging them, the order of question will be like the parts that you are doing earlier, they are going to help you in the later numbers you're going to do. So you have to be so careful here. So you see, I've got AB, AB helped me to get AM. Now, if I'm going to get OM, I'm going to use AM, which I've just got in part B. And that's how most of the numbers of vectors will be. So be very careful. Make sure you move with the parts. Don't leave part A, then you go to part D. Yeah. For vectors, it will become a little bit tricky. But there are some numbers where you can do that, but if they're not so connected. But for this case, you have to move in the order. It's better. I advise you to do that. Now, let us look at OM. I said we've already got our AM, so we can still use this. This one now can help us since I have AM. So I know that my AM is the same thing as having OM minus OA. So OM is the same thing as having OM minus OA. But now we have AM. Even if I want, I can make OM the subject. So it depends on what you want. If I want to get OM, I can take this OA this side. And when I take it this side, it becomes a positive. So it means that my OM, I can have still my OM to be the same thing as AM plus O plus OA. So I'll be having that. I'm just taking this one, this side. I'll be having that. So what I do next, I just come back and make substitutions. So we have already got our AM, which was 5 1. So I'll be having 5 1, then plus my OA. My OA was negative 2 2. So I have negative 2 2. So we add up this. So my OM becomes, so we have 5 plus negative 2 is like having 5 minus 2, which will give me a 3 here, and I have 1 plus 2, which will be 3. So this will be the answer to OM. That will be the answer there. That will be the answer. So you understand that AM is OA minus OA is good, or even somebody can still say, if I want to get AM, I can use AO, because I am starting from A. I can just see it's going to be AO plus OM. It's the same thing, and you get the answer right. So that's how we do it. That's how we do it. So that's number one. And what you're looking at here, most of these things you have already, now like this part C is okay, part A is okay. What you are looking at as a new thing today, these parts like part B, where we have to use the ratio as M dividing a line AB. That's what we are looking at as a new thing. But for part A and part C, we have been looking at such numbers. So we're going to look at the second question, number 2. Let's look at that number there. So number 2, they are giving us they're telling us that in a triangle OAB. So in this case, if you want, you can sketch the triangle. There's no problem. So we look at that. Please copy the question down. We're having our triangle OAB. And in this case, when you look at O, many times we are referring to O being the origin, because you are looking at position vectors. So we have OAB, then they are saying P divides line AB such that AP to PB. So write the question there. AP to PB, they are giving us the ratio as 7 to 3. So you have to be very keen, 7 to 3. And again, they are giving us OA. OA is given as A, and also they are giving us OB as B. So we have those things there. They're giving us OB as B, and they are telling us to find or to express in terms of A and B. You want us to find AB. That's our part A. You want also us to find AP. Then part C is asking for BP. And so we have lastly part D, which is asking for OP. Yeah. So look at number 1 was in terms of column vectors, and we had the numbers, usual numbers which are known or digits, but in this case we are having unknown. We're having these letters, and it's so good because most numbers they're expressed in terms of A, B, such letters. So we do this also. So first of all, we want us to find AB. So we look at what you have and see, can I get AB without anything else? Can I get AB? So even sometimes when you look at this, what we have, this line here, you can even draw a triangle, you know. You can draw it because sometimes this will be hard for you to interpret. But when you draw the triangle, notice that triangle was OAB. So I can draw a triangle. There's no problem in drawing it. So I can draw my triangle like that. Yeah, this is the triangle. And you have O, A, B. That's what I have. They're telling me that OA is given as A, so this represents the direction. This is OA is given as A. Also giving me OB as B. Ooh, OB is B, vector symbols. And again, they're asking me, they gave me something about the ratio. They're saying that AP to PB, that means that this P is dividing this line. So they are telling me that I'm putting it this side because if you look at AP is bigger than PB. So you have this, they're saying that AP to PB is 7. AP to PB is 7 to 3. Yes, that's what we have. That's our triangle. So after drawing it, then I can answer the question. I can look at what they want. First of all, they're asking for AB. Now AB, you can even use the triangle itself, the diagram. So we are looking at vector diagrams actually, because they can draw it for you. this case they didn't draw it, but you have drawn it for ourselves. So I can get AB in very many ways. One, I can use AB as OB minus OA. Also, I can say AB is the same thing as AO plus OB, because I want to see how can I move from A up to B. That's AB. So I just say AO plus OB. That's very fine. Also, even if I say AB is something as OB minus OA, we are going to do both and the answers will be the same. And if you look at this one, there's no way we are going to get maybe AB directly from. That's why we are expressing AB in terms of OA and OB. So let me do it, and we are going to use the two possibilities that we do have here. So one, I'm saying that if I want to get AB, if I want to get my AB from what we have been doing concerning position vectors, I can say AB is going to be the same thing as OB minus OA. And I'm saying we have been doing this from position vectors. So OB, we do have it. We have our OB, which is B. Let's come back and make substitutions. This is B. So say these are just vector symbols. So that becomes my AB. My AB is going to be like that. Yeah. In this case, I've just used the position vectors. But again, another person may not use that. I can use the diagram itself. I want us to see that if I use the diagram, it means that I'm going to move from, because I want to get AB. It means that I start from A. And what I do, just look at the diagram and I see how can I move from A to B. So in this case, if I'm to get AB using the diagram, so this is one way of doing it. But I just want us to imagine you don't know this. I want you to get it from the diagram. So AB still will be the same thing as getting AO, then plus OB. AO plus OB. But again, when you look at AO, said AO is negative OA. So the moment you reverse, because what they gave us was OA, which was A. Now when you get AO, it will be a negative. You put a negative in front. So this becomes negative A plus B. That will still be my AB. So look at this and this, they're the same. Or even if you say, you can organize it and say it's going to be B minus A. Yeah. So still it is the same thing. So we end up getting the same answers. Then next they want us to get AP. Now look at AP here. AP, you start seeing how am I going to work out AP. There, you can look at the diagram. So if you see, if I want to get AP, you can move and see, is there a possibility? One, I can say AO plus OB plus BP. I can get AP. So there are very many ways of working out these numbers, but the answers will be the same. You know, we have many ways, but answers will be the same. So another person can say AO plus OB plus BP. It is so fine. You will get the AP. Let me write for you here all the possible ways. So we are saying our AP can be equal to AO plus OB plus BP. So if you use this one, you get the answer. Another person can use this. I want to get AP. I can still use this because this is line AB. And if you look at this line, it means that AP is going to be 7 out of 10. The ratio is going to be 10. 7 out of 10 of AB. So I can still say that my AP is going to be equal to 7 out of 10 of AB, or times AB. And you have to assess and see which one is the easiest. If you look at this one here, it's easier than this. Because this one you have to find BP. Of course you have this and this, but you have to find BP. But this one is so easy. This one is so easy because I'm just going to, I already have AB, I'm just going to multiply by 7 out of 10. So I would encourage you to use this. But even if you do this, you get the same answers. Answers will be the same. Only that, again, finding BP is going to be almost the same thing as doing this. So you're doing a lot of work, yet you're going to get the same marks. But still, the answers will remain the same. So when I look at AP, I'm going to set my AP here. It's going to be 7 out of 10. Where I have my AB? I have my AB, so 2 brackets, B minus A. B minus A. So that becomes the answer. That becomes my AP. 7 out of 10 into B minus A. I've used this one here. Yeah. And again, in part C, they're asking me to find BP. You see, here you could get BP, but again, even part C is asking for BP. So you could reserve it, you go for this, then you work it out in part C. So part C again want me to find BP. And let's see how you're going to find BP. BP. So in this case, we are starting from B, going these ends. So BP is going to be 3 out of 10. 3, this portion of BP. Then 10, total ratio, when you add 7 plus 3. Then of BA. That's also a very common mistake. The moment you say of AB, then you B off. So you are supposed to say that BP is going to be, because you are starting from the ends of B, so it will be of BA. So BP is going to be 3 out of 10 of BA. That's how we are supposed to do it. 3 out of 10 of BA, like that. So we just come back and make substitutions. Here we need to get BA. Remember, BA is negative AB. Also, you can get BA because you know BA is OA minus OB. You can still get it, there's no problem. So I'll be having this as 3 over 10. Then BA is going to be OA minus OB. OA minus OB. So just make substitutions here. So I'll be having my 3 out of 10. 2 brackets, we have A minus B. This becomes my B. That becomes my BP. That becomes my BP. So that's how we work out that if you are to use the ratios so well, is that look at that portion of VP, then also you get total ratio, then also you have to be very careful. Am I starting from A? Am I starting from B? So most students will do this. They those work out 3 out of 10. Then now they use AB. So AB works only if I'm starting from this side. So AB will be okay if I'm getting PB. But if I'm getting BP, then you use BA. The next, they want us also to find OP. I want us to find OP. OP. So OP, you can still look at what we have. OP means that I can get OP in very many ways also. So OP can be, I can use OA plus AP. OB will be done. OP will be done. Also, even if I say OP is going to be OB plus BP. The good thing you have AP, also you have BP. So you can use any. OP is OB plus BP. That's how it will come out. OP still is OA plus AP. The answer still will come out. It will come out. But again, we can do it in very many ways. Yeah, you know, it's about understanding the vectors. Because look at this. I've already got my AP, and I want to get OP. I want to try to show you very many other ways of doing this that you don't need to cram. You see, I want to get OP, but I have AP, and I know that AP is the same thing as getting OP minus OA. So I get my OP. I make OP a subject, it will come out. And you find that this one is the same thing. Actually, it's the same thing as what you talked about. Even if you are using this BP, you can say still BP is going to be the same thing as OP minus OB. So still you get your OP. Or even if I go back to the diagram, there's no problem. It's all the same thing. And the answers will be the same. If you try to use this, you go back to the diagram, you get the same answers. So it's about understanding the concept. Then you work it out, the answers will be the same. So let me use the diagram. I'm going to use OA plus AP. So we say that our OP is the same thing as OA plus a p. Vectors just help us find the shortest distance. So you need to look at which one is easier, which one of the things that are involved, which ones are you having. For example, if I didn't have BP and I had AP, then this would be the best. But again, if in some of the parts they told me to get BP and I don't have AP anywhere obtained in some of the answers I have, then OB plus BP would be better because I have BP and I don't have AP, so it would be better. But since I have both, then I can use any. So you'll be coming here, you say it's going to be OA, which is A, plus AP. Already I have it here, don't waste time to get it again. Because then if you are giving marks, we give marks seeing that this one already you have it. Don't expect you to come back and go through all the steps. Just come and pick it, put it here. So I'll be having plus 7 over 10 into B minus A. So I want us to simplify this one because we have some common terms. A and A is here. So we can simplify it. Let's do that. We can get the LCM. LCM is going to be 10. So we'll be having 10. Then divide, this is like out of 1. By 1 you get 10. Multiply by this you get 10A. Then plus, here you just open back, you have 7B minus 7. So I want you to also understand how to open these. So I end up having my OP as this can be 10A minus 7A. I get my 3A. So 3A plus 7B out of 10. That becomes my OP, which you can still give as 1 out of 10 into 3A plus 7. Even if you open brackets, it's okay. But again, I prefer this because we're going to look at some numbers ahead. We ask you to prove that they are linear or they are to get the ratios. So that's how we work out that. Then there are numbers there that we have. We'll be trying them later, and also I can encourage you to continue, try them out, you get the answers. Also when we meet, we'll be doing most of those numbers. Thank you so much, and I encourage you to keep at BBSKATI.
Osomeseza omwana wo mu masomero ga Giant Schools omuli kampasi y'Ebombo Kalule n'eye Kabalagala kyobana bweraliikirivu bwonna olw'omusingi okutambuzibwa ebyenjigiriza n'ensoma y'abayizi ey'omulembe. Mu masomero gaffe gano gonna tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuuka ku siniya ey'omukaaga, nga tusomesa abaana okuviira ddala ku mutendero gwa kindergarten okutuuka ku kibiina eky'omusanvu. Tulina abasomesa abakugu mu kubangula abaana n'okubateekateeka. Ebibiina abaana mwe basomera eby'omulembe omuli buli kimu ekikwata ku ebyo bye basoma, ebisuula ebyazimbibwa obulungi, ebigazi ate nga biyonjo. Okumanya ebisingawo tukubire ku nnamba z'essimu ez'owammanga.
Baby Junior Jelly owulira omukwano gwa maama n'okufaayo kwa maama.